Hello students, welcome to my channel. In this video, I am going to discuss in detail about the electrochemical series and its significance. Coming to electrochemical series, it can be defined as the arrangement of metals in the increasing order of their standard reduction potentials. So, in this electrochemical series, all the metals are arranged in the increasing order of their standard reduction potentials. Students, what do you mean by standard reduction potentials? Let us consider copper. Always copper is having greater tendency to undergo reduction. That means the electrode potential is given with the positive sign and it will be called as reduction potential. Whereas moving to lithium, lithium is having greater tendency to undergo oxidation and hence its potential is given with positive sign plus 3.05 and it is called as the oxidation potential. What is the relation between oxidation potentials and reduction potentials, students? Oxidation potential is equal to minus reduction potentials. In this electrochemical series, all the metals are arranged with respect to the reduction potentials. Here, the oxidation potential of lithium is given with positive sign. That means the reduction potential is given with the negative sign. Is it clear, students? For our convenience, let us classify or let us divide the electrochemical series into two parts. Metals which are placed above hydrogen will have one type of behavior and the metals which are placed below hydrogen will have one type of behavior. In general, if we consider the metals which are placed above hydrogen, they are having greater tendency to undergo oxidation. What is the tendency of metals placed above hydrogen? They are having greater tendency to undergo oxidation and hence they can act as anode. So how they can act? They can act as anode and thus they can act as best reducing agents. Thus, they can be called as active metals. So, the metals which are placed above hydrogen are having greater tendency to undergo oxidation and they can act as anode. With the result, they can be used as best reducing agents and all these metals are called as the active metals. Generally, they include alkali metals, alkali earth metals and some d block elements. Clear, students? Coming to the metals which are placed below hydrogen, they include noble metals and they are having greater tendency to undergo reduction. So these metals are having greater tendency to undergo reduction. So they can act as cathode. That means they can be used as best oxidizing agents. Clear, students? So the metals which are placed below hydrogen are called as noble metals. They can act as cathode. Why? They are having greater tendency to undergo reduction more readily. Thus, they can act as cathode and they can be used as best oxidizing agents. Along with the noble metals, here halides are also present. So, from this series, it is very clear that the metal which is having lowest standard reduction potential is lithium and the metal which is having highest standard reduction potential is fluorine. So, which of the following metal occupies the top position? That is lithium. And which of the following element occupies the bottom position in electrochemical series? That is fluorine. Clear, students? Now, let us discuss about the significance of electrochemical series. Coming to the significance of electrochemical series, generally, the metals which are higher in the electrochemical series undergoes oxidation more readily and acts as anode. As I said earlier, definitely the metals which are higher in the electrochemical series will act as best reducing reagents, and they undergoes oxidation more readily and can act as anode. Whereas, if we consider the metals which are placed below the electrochemical series, they readily undergoes reduction and hence act as cathode. They can act as best oxidizing reagents. Clear, students? So let us see few examples. Whenever if we consider zinc and copper, you try to identify which metal acts as the anode and which metal acts as the cathode. So from the position of the metal in electrochemical series, we can predict which metal can act as cathode and which metal can act as anode. Always the metal higher in the electrochemical series acts as the anode. So from these two metals, it is very clear that zinc occupies the top position and hence it acts as the anode, whereas copper acts as the cathode. Clear, students? From the position of the metals in electrochemical series, we can predict which metal will act as anode and which metal can act as the cathode. Let us see one more example. Between iron and nickel, try to guess which metal will act as anode and which one will act as the cathode. From this electrochemical series, it is very clear that iron is higher in the electrochemical series and hence it is having greater tendency to undergo oxidation and will act as anode, whereas nickel will act as the cathode. Clear, students? So here when we see the electrochemical series, the reducing tendency of metals decreases from top to bottom of electrochemical series. Once again, let us see the electrochemical series. So from this electrochemical series, it is very clear that the reducing power is decreasing from top to bottom, whereas the oxidizing power is increasing from top to bottom. That means lithium is the best or strongest reducing agent, whereas fluorine is the strongest oxidizing agent. Is it clear, students? So, as we move from top to bottom of electrochemical series, the reducing power decreases, whereas the oxidizing power increases. That means lithium is the strongest reducing agent, whereas fluorine is the strongest oxidizing agent. Clear, students? In the similar way, it is possible to predict the replacement tendency of metals. So, in general, the metals which are placed above hydrogen can easily liberate hydrogen from dilute acids or from water. On the other hand, what happens? The metals which are placed below hydrogen are less reactive and they do not liberate hydrogen from the acids or from the water. So from the electrochemical series, we have to remember the position of metals. Always remember the noble metals are placed below hydrogen and the remaining metals are placed above hydrogen. So these metals are called as active metals, and all these metals are capable of liberating hydrogen from the acids or from the water, whereas the metals which are placed below hydrogen are noble in nature, and hence they do not liberate hydrogen from the acids or from the water. Let us see few examples. For example, whenever zinc is treated with HCl, what happens? Definitely, zinc is an active metal, so it readily liberates hydrogen gas from the acid. Whereas if copper is treated with HCl, then guess what happens? Copper is present below the hydrogen and it is less reactive. There will be no reaction. Clear, students? If the metal is placed above hydrogen, that metal is called as active metal and capable of liberating hydrogen from the acid. Whereas if the metal is placed below hydrogen, that means it is noble metal and it do not replace hydrogen from the acid. That means there will be no reaction. Similarly, let us consider few more examples. Whenever nickel is treated with HCl, guess what happens? Similarly, when silver is treated with HCl, what happens? Just pause the video for a moment and guess. Whenever the nickel is treated with HCl, nickel is present above hydrogen and it is the active metal. It readily replaces the hydrogen. That means it liberates hydrogen gas from the acid. Coming to the silver, it is present below the hydrogen and hence it is noble, thus there will be no reaction. Clear, students? So from the position of the metal in electrochemical series, we can predict whether the reaction is spontaneous or not, whether the reaction takes place or not. Clear, students? In a similar way, it is possible to calculate EMF of the cell from the position of metals in electrochemical series. As we all know that EMF of the cell can be calculated by using the formula E cell is equal to E cathode minus E anode. Always remember, here we have to consider standard reduction potentials. So EMF of the cell is equal to E cathode minus E anode. Let us consider one example. So calculate the EMF of the cell consisting of zinc and copper electrodes. The reduction potential of zinc is minus 0.76 volts, whereas the reduction potential of copper is plus 0.34 volts. So initially we have to identify which metal will act as cathode and which metal will act as anode, and that is very clear from the reduction potentials. The metal with higher reduction potential always will act as cathode. Clear, students? A metal with higher reduction potentials always will act as the cathode and the other metal will act as the anode. Right? So in this example, copper is having greater reduction potential, hence it acts as the cathode, whereas zinc having lower reduction potential, it will act as the anode. So the EMF of this cell is equal to E copper minus E zinc. That means 0.34 minus of 0.76. So that is equal to 1.1 volt. If the EMF of the cell is positive, we can predict that the reaction is spontaneous. Clear, students? So, if the EMF of the cell is a positive quantity, then the reaction is spontaneous. The reaction takes place. In a similar way, we can also consider one more example. Calculate the EMF of the cell consisting of iron and nickel electrodes. The reduction potential of iron is equal to minus 0.44 volts, and the reduction potential of nickel is equal to minus 0.25 volts. Students, pause the video for a moment and guess which metal will act as cathode and which one will act as the anode. Undoubtedly, a metal with higher reduction potential will act as the cathode. So, in this case, nickel will act as the cathode and the iron will act as the anode. So, simply we can calculate the EMF of the cell by using the formula E cathode minus E anode. Here the cathode is nickel, whereas the anode is iron. So EMF of the cell is equal to E cathode minus E anode. That means in this case, E electrode potential of nickel minus electrode potential of iron. That means minus 0.25 minus of 0.44, that is equal to 0.19 volt. So here also the EMF of the cell is a positive quantity and hence the reaction is spontaneous. Clear? So in this way, by calculating the EMF of the cell, we can predict whether the reaction is spontaneous or not. Coming to the another application, it is possible to predict the displacement tendency of a metal with another metal from its solution. That means if the metal is higher in the electrochemical series, it can easily displace a metal which is lower in electrochemical series from its salt solution. Simply, whenever the zinc is treated with copper sulfate solution, what happens? Zinc is higher in the electrochemical series. So it is highly active. It readily replaces the copper from the copper sulfate solution. So we will get zinc sulfate and the copper will be precipitated. Whereas whenever the copper is treated with the magnesium sulfate solution, then what happens? Copper occupies lower position in electrochemical series. That means it is noble in nature. It cannot replace magnesium from magnesium sulfate solution and hence there will be no reaction. Is it clear? Always the metal which is higher in the electrochemical series can replace the metal which is lower in electrochemical series from its solution. Clear, students? In other words, we can predict whether a copper sulfate solution can be stored in a zinc container or not. That means here zinc is made as container. That means the lower metal is made as the electrolytic solution. So definitely zinc reacts with copper sulfate solution. That's why copper sulfate solution cannot be stored in a zinc container. Whenever you are supposed to answer, can copper sulfate solution be stored in a zinc container? You have to identify the container should be made up of a metal which is lower in the electrochemical series. Here, container is made with zinc which is higher in the electrochemical series, and it is highly reactive. It spoils copper sulfate solution. That's why copper sulfate solution cannot be stored in a zinc container. Let us apply it to the second example. Can magnesium sulfate solution be stored in a copper container? Here, the container is made up of copper, which is lower in the electrochemical series. So, it is noble when compared with the magnesium. So, there will be no reaction, and we can store magnesium sulfate in a copper container. Why? The standard reduction potential of copper is greater than the standard reduction potential of magnesium. In this case, copper will not react with magnesium sulfate solution, and hence we can store magnesium sulfate solution in a copper container. Is it clear, students? Finally, I wish to conclude this video with a test question. Why copper is precipitated out when zinc piece is kept in copper sulfate solution? Clear, students? When a zinc piece is kept in copper sulfate solution, automatically copper will be precipitated out. You have to guess why copper will be precipitated out. Thanks for watching. Have a nice day.